Good evening. I had several people that missed all of the lecture on Monday night, and we were having trouble getting the Zoom cameras and stuff to work. So I just thought I would sit down here tonight and go ahead and record that lecture so that I can post it for those that missed it. And I hope that that's helpful to you. We were talking about hydraulics and power brakes, some of the hydraulic components that we use on our brake systems, and so we'll get into the lecture here and talk about that just a little bit this evening. Again, our wheel brake units are applied by using the principles of hydraulics. We've mentioned some of those principles of hydraulics in class already. So the brakes are applied by the force transferred by non-compressible brake fluid flowing through brake lines and hoses. We know that a liquid like brake fluid will not compress. Air, on the other hand, will. It's one reason we have to make sure that we don't have any air in the system, because the air will compress. A liquid won't. So a liquid will, instead of compressing, it will transfer the force of the master cylinder out to our brake units. A power booster can be fitted to the brake system to increase the driver's pedal force to the master cylinder, and it can be operated by engine vacuum or hydraulic pressure. So when we have power brakes in these cars, basically the power brakes are going to do are just help us to apply the brake pedal, less effort on the driver's part, and have good pedal force to the master cylinder. And those can be operated by engine vacuum. We can just take vacuum off the engine and help with that power brake system, or we can use the hydraulic pressure that we get from the power steering pump. This is a real simple dual hydraulic braking system. We've talked some about single brake systems and dual systems. This would be a dual system. It's got a master cylinder that's got two separate reservoirs. This reservoir and this brake line goes out through a proportioning valve, which we'll talk about in a little while here. But this goes through that proportioning valve out to the rear brakes to apply the rear brakes. This rear reservoir just comes out and goes up to the front brakes to apply the front disc brakes. So that way, if we lose the front brakes, we've still got the rear. If we lose the rear, we've still got the front. That's the purpose of a dual cylinder. This is the brake booster. It's what the brake booster is going to look like. Some of the principles of hydraulics, and again, we've touched on this a little bit in class. Pascal's law, and this is something very important for you to learn and remember. It states that pressure applied to a fluid in one part of a closed system will be transmitted without loss to all other areas of the system. So what that means in essence is, if we have a closed system, if we have a hydraulic system that there's no leaks, then the pressures, when we apply pressure to that, the pressures within that system are going to be the same no matter where we check it. If we apply the brakes and we check the pressure right outside the master cylinder, the pressure is going to be the same as it would be at the wheels or anywhere else in that system. So as long as the system's closed and we have no leaks, then the pressures are going to be the same all the way through the system. So pressure created in the master cylinder is transmitted through the hydraulic braking system as long as the system remains closed and it has no leaks. If we have a leak of some type, we're not going to be able to build up any pressure, so we're not going to be able to apply the brakes. And this kind of illustrates that just a little bit here. We've got a single master cylinder here where we've got one master cylinder that's feeding all four brakes, but we've got no leaks. So when we apply the brake pedal, you look at the pressures at all the wheels. The pressures are the same all the way through the system, as it will be. Here's one that has a leak. The left rear, we've got a leak at the left rear brake here. And because this is a single system, single master cylinder system, because we have a leak back here, if you notice here, we've got zero pressure in any of the wheels. So we've got no stopping power whatsoever in this situation. Pascal's law helps in diagnosing problems with the hydraulic braking system. If the brake pedal sinks to the floor, it's likely a small leak in the system. That could also be a problem with the master cylinder. If a vehicle pulls to one side, it could be that a brake hose is plugged up and not transmitting pressure to one of the brake units. As these brake hoses, the rubber hoses, they are notorious for coming apart inside the hose. It looks fine on the outside, but it deteriorates and comes apart on the inside where it won't let brake fluid move back and forth as it should through the hose. This is a little bit more of that hydraulic principle. You know, even though we talked about in a closed system, our pressure is going to be the same. If we want more clamping force or more output force, the way we're going to do that is to increase the size of the piston or increase the number of pistons that we're pushing on. So again, we've got the same input force here at all three of these pistons, but we have a larger diameter, a larger surface here that we're pushing on, so we get more output force. So if we want more pressure to our front brakes than we do to the rear brakes, we're just going to use a larger piston on our brake calipers in the front. And the larger the piston, and the more surface area that we have that we're pushing against, the more output pressure we're going to have. So the same pressure applied over different size surface areas will produce different levels of force. And again, the larger that surface area, the more force. Now, we could do the same thing if we had, you've heard of 2-piston calipers or 4-piston calipers. Same thing, by adding more pistons, we're increasing the surface area that we're putting the hydraulic pressure on. So we're getting more clamping force or more output pressure. For vehicles to brake smoothly, more pressure must be applied to the front brake units than the rear. The larger brake pistons on the front wheels give greater mechanical force and braking power to the front wheels. So because we need more pressure on the front wheels, we just use a larger piston in our brake calipers, and that gives us the output pressure that we need to make those wheels work in the front, those brakes work in the front. 3 variables to consider when talking about pressure and force in hydraulic systems: input force, working pressure, and output force. And there's a picture here that kind of describes that a little bit here. Here's our working pressure. We've got 100 pounds of input pressure. You notice that we put it in, and again, throughout this whole system, now it's a closed system, so it's going to be 100. It's going to be 100 psi. All these areas in yellow here, if we was to check the pressure, it would be 100 psi. But you notice that we have a larger surface area up here on this one, so we've got 300 pounds of output pressure. This one's a little smaller. We got 200 pounds. This one has got the same size piston on the output as the input, so the 100 pounds stays the same. And then as we get smaller, we have less output force. Hydraulic system is made up of a number of components that work together to transmit the driver's effort to the brake pads or brake shoes. It must be able to withstand the force, pressure, and temperatures generated in the brake system. Brake fluid is a very important part of the brake system. It's a hydraulic fluid used to transfer force while under pressure. It's used to transfer force while under pressure through hydraulic lines to the wheel braking units. So the brake fluid is what we're going to use to transmit that force, build it in the master cylinder, and transmit it out to the wheels. Brake fluid must have a high boiling point to remain effective under extreme temperatures. Must have a low freezing point so it won't freeze or thicken in cold conditions. So brake fluid is used in a lot of extreme environments, whether it's well below zero, or whether it's it's 110 outside and you're in stop and go traffic and using your brakes a lot and they're very hot. That brake fluid still has to do its job. It still has to perform and transmit our power from the master cylinder to our brakes. So it's a very important part of the braking system. Something else to remember about it: it can damage paint. If you spill some of this on somebody's paint on their car and their fender, you need to get that off immediately, because it can damage those and soften paint, and it can damage the. I talked some when we were in safety class. I talked quite a bit about using fender covers and those types of things to protect a person's car, the customer's car. If you use a fender cover, you're never going to embarrass yourself by having something like this happen. You really lessen the possibility of that happening when you use those fender covers. So that's always a really good idea to do that. But just remember that brake fluid on paint can cause real problems. Standard brake fluid is what's called hygroscopic, which means it's absorbed water. Now, some of the synthetics is not that way, but dot 3 and dot 4 I know for sure are hydroscopic. So what that means basically is if I'm going to put some brake fluid in a car and I take the lid off of it and I use that brake fluid, I top off the master cylinder and I set the brake fluid can back on the workbench and I forget to put the lid on it, and it sits there overnight or for a day or two. In my book, that brake fluid is junk and needs to be thrown out. It will absorb enough moisture out of the air that it's no longer good to use. It says it can even absorb moisture through flexible brake hoses. So it's really prone to absorb a lot of moisture. And this says water absorption will gradually reduce the brake fluid's boiling point and cause hydraulic braking failure. Remember, water boils at 212 degrees, and man, some of those brake calipers out there on the end, when they get hot in stop and go traffic or whatever, they get a lot hotter than that. So any moisture, any water that's in there is going to try to boil at that point. Plus, it causes corrosion and contamination in the brake system, and any moisture in there is just not a good idea at all. Same thing with your brake fluid cap when you're checking the brake fluid. Man, get that, if you're checking it, go ahead and check the brake fluid and get that cap back on there. We don't want that brake fluid absorbing moisture. It should be flushed periodically to replace the old contaminated fluid with new fluid. I think a lot of manufacturers recommend every couple of years. It's going to be different, of course, for each vehicle. Some place you're going to look in your shop manual to find out. But a really good way to do that, and we'll do this some in class, we have what's called a pressure bleeder, and it's basically a tank with new brake fluid of the correct type. It's got an air fitting in the bottom and a big diaphragm in it. So we put a little bit of air pressure, just a few pounds, 8 or 10 pounds of pressure at the most. And it pushes on that diaphragm and pushes brake fluid out the top of it through a hose. And we put that on the top of the master cylinder. And so we've got pressurized fluid going into the master cylinder. We can just go out to all the different wheels, start off with the one furthest away from the master cylinder, so the right rear, and just open up that bleeder screw and watch all the old cruddy fluid come out until the fluid looks good. Close the bleeder screw and then move to the left rear and then the right front and then the left front. When you're all done with that and you've flushed out all four wheels, you flushed out all the calipers, all the brake lines, all the brake hoses, the master cylinder, any ABS components. So you flush clean brake fluid through all those and you have clean brake fluid in it. So it's a good idea to do that every now and then, and pressure bleeder is a real nice way to do that. And again, that's something that we'll be doing in the lab later in the class. Brake fluid is graded against compliance standards set by the DOT, by the Department of Transportation. It is tested to meet standards for pH or acidity, pH value, viscosity, which is the thickness of it, resistance to oxidation, the stability of it, and its boiling point. Master cylinder, of course, is a very important component in our brake system. It's kind of where everything starts. It's going to be mounted to the firewall. It has to have some means, some mounting ears, where we can bolt it to the firewall. Here's a rod that comes from the brake pedal. So when this goes forward, it's going to push this brake fluid, overcome a spring here, push brake fluid through this residual pressure valve out into the brake system. This, of course, is just a single master cylinder. It's got threaded passageways to which the brake lines firmly connect. It's got a reservoir that supplies the brake fluid into the master cylinder. It's operated by a push rod from either the power brake booster or the brake pedal. Single master cylinder, and guys, there's not very many of them out there anymore. Almost everything out there is a dual or a split system now. But I've got an old Mustang 65 that originally was a single master cylinder setup. If you lost brakes at any wheel, you just didn't have any brakes on the car at all. So I bought a retrofit kit and I put a dual type cylinder on it to where now it's split front to rear. And if I lose front brakes, I've still got rear brakes and vice versa. I was talking about single cylinders now. Has one piston with two cups, a primary cup and a secondary cup. And they're known as seals because they keep the brake fluid from leaking past the piston. The primary cup seals pressure in the cylinder, while the secondary cup prevents loss of fluid past the rear end of the piston. So we got a rear seal here that's going to keep fluid from from pouring out the back of the master cylinder. And this front one is what's going to seal this brake fluid and push it forward, and push the brake fluid out into the brake system when we apply the brakes. It says an outlet port links the master cylinder to the brake lines, and an inlet port connects the reservoir with the space around the piston and between the piston caps. Right here's our inlet port. It's going to let the fluid come in. Of course, here's the outlet port. A compensating port connects the reservoir to the cylinder, and that is going to be right here. Notice that is open as long as the piston is back. As soon as we start pushing this piston forward, it's no longer connected to this pressure reservoir here where we're pushing out brake fluid. With the brake pedal in the released position, the compensating port connects the brake system with the reservoir, again, right here in the released position. The compensating port adjusts for changes in the volume of the brake fluid ahead of the piston, and also compensates for brake fluid that doesn't return to the master cylinder due to worn brake pads. On disc brake cars, as the disc brake pads wear, as the pad gets thinner because of wear, the way we compensate for a thinner brake pad is the piston and the caliper just stays out of the caliper a little bit further, and it stays up against that brake pad, and so we have to fill in behind that with brake fluid. So in a disc brake car, it's normal for the fluid level to go down slightly each time you check it. You may have to top it off from time to time. The compensating port adjusts for changes in the volume of the brake fluid. Okay, we've read that. When the brakes are released, the master cylinder piston returns to its original position by the action of the spring, and that's this spring right here. When we push forward, we push out fluid. When we let off the brake pedal, the spring pushes it back into the original position. When the pedal is released quickly, the spring of the brake pedal pushes the piston back quickly. Small holes are drilled in the piston so that the brake fluid from the reservoir can pass through the inlet port and past the edge of the primary cap, thus preventing a vacuum from being created. So we don't want to create a vacuum in this system, so that's where these little slots here come in. All right. The residual pressure valve, which is in the end of the cylinder here, is right here. It holds the brake pressure slightly above atmospheric pressure when the brake fluid in the lines returns to the master cylinder. So its residual pressure valves are not used on disc brake cars. So if we have a disc brake car, we won't have a residual valve in it. Now we're going to talk about a tandem master cylinder, or a dual master cylinder, or a split system, as some people call it. It combines two master cylinders that share a common cylinder bore and a common housing. So basically it's two master cylinders in one. Has a primary piston and a secondary piston. The primary piston's in the rear of the cylinder and is pushed directly by the push rod, and the secondary piston's in the front of the cylinder and has a rear-facing seal that seals fluid in the primary chamber and ultimately pushes the secondary piston during normal operation. So here we go. Here's our rod coming from the brake pedal. Here's our primary piston. It's going to push fluid out here, and this is going to go to the front brakes. The pressure there is eventually going to push this secondary piston forward, and it's going to push brake fluid out here to go to our rear brakes. Notice we have two reservoirs, and they're completely separate from each other. So if we lose all the fluid in this reservoir, this system's still going to work. So we basically have two complete master cylinders here in one unit. Dividing the reservoir prevents all the fluid from leaking out due to a leak. With both pistons moving forward, they displace fluid into their separate circuits and apply the brake units for each wheel. So as these things move forward, they're going to push fluid out to the rear brakes and the front brakes. Here we've lost our brake fluid in this reservoir, but this one is still going to work. It's still full of brake fluid, so we're still going to have rear brakes. We just wouldn't have any front brakes in this instance. So what would happen with this up here, we wouldn't be able to build any pressure to push this forward. So there's a rod attached to the front of the primary piston, and this rod that's attached, it would go ahead and push this secondary piston forward to go ahead and generate brake pressure to the rear brakes. Quick take-up master cylinders. That's what a quick take-up master cylinder does on some vehicles with disc brakes on the front. They have a spring. Some of them have a spring attached to the brake pad where it mounts in the caliper that actually pulls the pad away from the brake rotor. So there's a space, not a lot, but a little bit of space between the brake pad and the brake rotor. The reason they do that is they don't want any friction at all. So that there's no power loss there. And no heat generated, so they do that. One way they do it is there's some little springs. I know Ford uses a little spring that goes in the end of the brake pads that pulls them out, but also inside that brake caliper, we have a bore there with a piston in it, and there's a seal that goes around that bore. But what happens is when the brake fluid tries to push that piston out, it distorts that rubber seal a little bit as it's trying to go out. And when we release the brake pressure, it kind of has a rubber band effect and pulls the piston back a little bit. So what it does is it pulls the piston and the brake pad away from the rotor just a little bit, so that there's no friction. We're not touching. On most of them, the brake pad sits right up against the rotor, but there's no pressure on it, so there's not a lot of loss or anything. But on a lot of them, they don't want them touching at all. So they have a gap between the pad and the rotor, and that works fine. Obviously there's no friction there. But the problem there is when you go to apply the brakes, you have to take up that space before you actually start getting any braking action. So they have what's called a quick take-up master cylinder, and what it does is in the rear of the cylinder here, if you notice, it's got a larger bore size here. And what it can do is it can move a lot of fluid in a hurry. So it'll move up to where it displaces that fluid and it gets those pads pushed up against the rotor. And then we go back to our normal bore size on our master cylinder. So it's used on the brakes, disc brake systems that are equipped with low drag calipers. It uses a relatively large diameter piston in the rear of the cylinder to push a large volume of fluid into the hydraulic system at low pressure. Designed to maintain a larger running distance between the disc brake pads and the rotor. Once pressure rises above a predetermined point, so that's when the pads meet the rotor, a quick take-up valve opens and bleeds off any extra pressure created by the large piston. So that's when we go back to our normal bore size. ABS master cylinders. Now, they talk a lot here about ABS master cylinders, and please understand that Ford is going to have a half a dozen different ABS systems, GM more than that probably, and Toyota and Nissan. Everybody's got their own system. We're all a little bit different. So what we're going to talk about here with ABS master cylinders just a little bit, and they just sound a whole lot like a dual braking system. They've got a tandem master cylinder, just like a dual system. It's used in divided system, has a primary piston and a secondary piston. The primary chamber uses a compensating port and inlet port, just like the other. The secondary piston incorporates a center valve that controls the opening and closing of a supply port drilled into the piston. Now, that's a little different. It says that rests the supply ports open and connects the reservoir with the front brake circuits. When the brake pedal is applied, the primary piston moves and closes the compensating port. Brake fluid pressure in the primary circuit rises and causes pressure buildup in the secondary circuit and applies force in both circuits. That's a whole lot like the dual master cylinder setup. When the brake pedal is released quickly, recuperation happens. When the piston has returned to the rest position, the seal is pulled off its seat by the action of the link and a spring, and the amount of brake fluid that returns to the master cylinder is determined by the ABS control. So again, with ABS, we're going to have some computer controls involved, and again, when you get into ABS systems, that's where your shop manuals are going to be involved. You need to be sure and check those and make sure that you, for all the different types of vehicles. Reservoirs, we'll talk about reservoirs and float switches in the master cylinder. Now, this is a cast iron master cylinder here. Here's the mounting point for it. This is the cap for it. Understand now this cap has got a big rubber seal on the bottom of it to seal these reservoirs. And notice that we've got two reservoirs here. One of them is a lot bigger than the other one. Remember that with disc brakes, it's normal for a reservoir to go down just a little bit as the brake pads wear. So this big reservoir, the one in the rear here, would be for the front brakes. This would be used on a vehicle that had front disc brakes and rear drum brakes. So the reservoir can be built into the master cylinder like this one is, and the reservoir cover on these cylinders must be removed to inspect the brake fluid level. So on these two, if you're going to see how much brake fluid you got in it, you got to take the cover off. Remember what I said, don't leave this open. Go ahead and check it, get the cover back on it. Another style, this one, instead of being cast iron, it's got an aluminum housing, and it's got a plastic reservoir. The reservoir has got a minimum and a maximum mounted on the side of it. You don't have to open the system up to check the brake fluid. You can look right through the side and see how much fluid it's got on it. It says on two-piece master cylinder, the reservoirs are usually made of a see-through plastic material that uses grommets or O-rings. So where this reservoir pushes into the master cylinder, it's just got some rubber grommets there to keep it from leaking. It says to ensure that a leak in one circuit does not affect the other circuit, master cylinder reservoirs have two separate chambers. Again, just like the other, we've got two separate chambers inside this. So if we lose fluid out of one side, the other one would still operate. You notice this has got an electrical connector on it. Now that electrical connector goes to this float switch. So you notice on this one, there's a float in here. It floats in the brake fluid. It's setting nice and high. Everything is good. On this one, it's low, so we were low on brake fluid, so this float has come way down. When it does, this little magnet and this reed switch will set, and it'll close this switch. When it does, it provides a ground for this bulb, and you have a light that's on the dash that just says brake, and it'll come on. And when you see that, you can go out here and check your brake fluid. It's low. You put a little brake fluid in it. The light should go out. So remember that brake light on the dash. This float is one way that we can turn that light on, but we're going to find out there's 4 different ways that we can turn that same light on. Guys, if you're low on brake fluid, it may just be because your brake pads are worn some, but it may also be because you've got a leak. So be sure and put your mind at rest that you don't have a leak before you do this. Now, when you're talking about brakes, be extra careful. Most modern master cylinder reservoirs are equipped with a low brake fluid level float switch, which we were just talking about. The brake fluid level could be low due to worn brake pads or a leak in the system. And adding brake fluid without further investigation into what's causing low brake fluid could lead to brake failure. So if it's low on brake fluid, figure out why. Brake pedals, we've talked some about brake pedals, and we've talked about their mechanical advantage because of the way they're mounted. If you look at this again, where it's mounted up here and where his foot is on this brake pedal, he's got a lot of leverage to push on this. When he pushes the pedal down, obviously it pushes this rod forward. This is your power brake booster. The red thing here is the firewall. That's where everything is bolted on. So it says the leverage to multiply the effort from the driver's foot to the master cylinder should be mounted securely and free from excessive sideways movement at a convenient height and angle. So it's mounted up under the dash where you can get to it easily, and it's nice and comfortable. So when you apply the brake, when you step on it, you've got a lot of leverage. You can apply a lot of force to this and to your master cylinder. Now remember this little float switch in here that tells us when the brake fluid's low? That controls the light on the dash. We come over here and we've got another type of a switch. And this is just your brake light switch that controls the lights on the rear of the vehicle when you step on the brake. So this is your actual brake light switch in the rear. Still talking brake pedals, usually suspended from a bracket between the dash panel and the firewall. The push rod transmits the brake pedal force either directly to the master cylinder or to a brake booster. When it goes to the brake booster, there's going to be another rod in the booster that's going to go ahead and transmit that to the master cylinder. When the brake pedal is applied, a lighter spring in the brake light switch causes the brake light contacts to close and activate the brake lights. So back here to this little brake light switch, when we move the pedal in this direction towards the firewall, there's a little spring-loaded plunger in here, and it's allowed to move forward. When it does, it closes a contact and it turns on our brake lights. Generally speaking, these brake light switches up under the dash are pretty easy to get to, pretty easy to service, adjust, replace, whatever you need to do. Understand that it may have an extra wiring harness on it because a lot of vehicles that have cruise control, when you step on the brake, it releases the cruise control. So you might see 2 electrical plugs coming off of this rather than 1. Some vehicles come equipped with adjustable pedal assemblies, usually electrically driven motors that are operated by a switch on the steering column or dash. So they're showing this here as having a switch. Guys, a lot of these now too are adjustable, are controlled by a computer. And so the adjustable pedals. My wife has got a new GMC Acadia, and when she goes in that thing and sits down, and she's got her key fob, man, it adjusts the pedals and the seat and all that stuff to her driving. And the other key fob, if we set it up for me, which I hardly ever drive her car, so we haven't done that. But if I'd done that, whenever I get in there and I put my key in the position, it would adjust everything for me. So, but on this particular one here, it's got a switch on the dash that adjusts that pedal height where you can get it comfortable. This one obviously is quite a bit lower than this one is. A wheel's braking ability depends on the load that it's carrying. On a front engine rear wheel drive car, has about 40% of its load on the rear and 60% of its load on the front wheels. Its braking system can be split, can be divided in vertical, or it can be a front rear split. And what they mean by that is, we talk about this dual system where if one side goes out, we still have the other. Now, a lot of times those are split front to rear. So if the front brakes go out, you've still got the rear, or vice versa. But now a lot of them are split diagonally, where the right front and the left rear are hooked together. The left front and the right rear are hooked together. So if you have brakes go out somewhere, you've got one front wheel and one rear wheel still applying the brakes. And that's called a diagonal split. So on front wheel drive vehicles, guys, with a front wheel drive car with the engine in the front and the transaxle in the front and all that stuff, there's so much weight on the front and so little weight in the back that rear wheels could never stop that vehicle. You never have enough weight on the rear. Your stopping distance would be astronomical. So they use a diagonally split system, so that you always have one front wheel trying to stop the vehicle. And this just shows a little bit of that here. Here's one that's split front to rear. This one goes to the front, and this one goes to the rear. And here's one that's looks like, yeah, this is diagonal. It goes to the right front and the left rear, and then to the left front and right rear. Now these proportioning valves, we'll talk about them in a little bit, but just notice one thing here on these proportioning valves. We've got a split system here that's diagonal across, and we've got two proportioning valves, and we'll talk about what a proportioning valve does and why it needs two as we move along here. Brake lines and hoses. The brake lines, they carry fluid from the master cylinder to the brake units. For most of their length, they're double wall steel, coated to resist corrosion, and attached to the body with clips or brackets to minimize damage from vibration. And guys, if you look at these brake lines, they're mounted up tight to the body. They'll have little retaining clips all along the body. They don't want those things to hang down or stick out and get hung up on something or anything like that. So they're going to be attached and held up nice and tight to the body all along the vehicle. And then we have flexible hoses to allow for steering and suspension movement. So, remember that our braking units, either on the front or rear, are out at the edge, completely out at the wheels. So on the front, we have to allow for suspension movement up and down, and we have to allow for the wheels moving side to side when we turn. So we have to have a flexible hose there. If we run a steel line all the way out to the wheels, that just wouldn't work. It would eventually break. And then same thing in the rear. When we go to the rear axle housing, that suspension is going to be moving up and down, and so we have to have a flexible hose back there also to allow for that suspension movement. And this is just pointing out one of the steel brake lines here, and this is pointing out a rubber or flexible line in the front. Brake line materials must be able to transmit considerable hydraulic pressure, 1500 psi or more during panic stops. They're made of seamless double wall steel. Must conform to the standards set by SAE, or Society of Automotive Engineers. It says here, replace the entire brake line with a factory replacement rather than repairing it. That's great. It's not always practical. Sometimes you're going to have to just buy a section of brake line and cut it to length and bend it to make it work and then put new flares on the end of it. We'll be doing that in the lab some. We've got some tubing benders and we've got the flaring tools to do that. But guys, the one thing that's important to remember is you have to use the right material. You have to use a brake line, something that's made for that. I've seen people try to use copper tubing and stuff like that on brakes. And I'm not sure it's even legal, but it's certainly not the proper thing to use. Well, this, I said we would be making some flares on the end of brake lines. This is what we're going to look like. You know, so what we would do if we had a piece of steel brake line and it was too long, we needed to cut it off. We would just slide this fitting back. Remember, the fitting has to be on before we make the flare. You can't put it on later. So we would just move this flare back, and we've got a little cutoff tool that cuts that off nice and square, and we can cut it to length, and then we can remake this double flare on it. Now, the double flare is going to seal to this cone shape in the master cylinder here. This one looks like bolts to a master cylinder or a wheel cylinder. And you see how that cone is going to match up here, and you're going to get a nice tight seal. And we'll do some of these double flares when we're out in the lab. Another type used, and this is on a little bit later cars, it's called an ISO flare. I think we've got the tooling to do those also. And so we'll try to do some of those when we're in the lab too. This just shows trying to take these lines loose where you're holding one side with a wrench and turning the other. I don't know if you've ever used what I call line wrenches. Some people call them flare nut wrenches. They look like a 6-point closed-in wrench, except they have an opening in them to slide off these lines, and you're a lot less prone to rounding off the corners on these lines with that type of wrench. And we'll be using those out in the lab too. Again, the brake hoses, flexible hoses transmit the brake system hydraulic pressures to the wheel units. They must be tough as not to be damaged easily. And when replacing them, always make sure they're the proper length. Now, a couple things to notice here. Here's our brake hose going down through here and hooking to a brake caliper in the front. Notice how it's tied up here to the strut and the firewall in nice and tight. You don't want that thing hanging out there where it's going to rub on the tire or the suspension components or anything like that and be damaged. Make sure they're the right length. If you get one that's too short, then when you turn it all the way to the extreme, it's liable to try to stretch that hose and damage it. If it's too long, you're going to have a length of it hanging out here somewhere that's going to be susceptible to hitting something or getting caught up or rubbing on a tire or something like that. So you don't want them too long or too short. You just want the right length. So compare those and make sure you get the right ones. And here's kind of a cutaway of one of the hydraulic brake hoses. Man, they're made out of good stuff. They really are. Now, these are a little pricey. These are kind of probably $50-ish, something like that. They're up there. But remember, we're talking about brakes. Be very conservative and very methodical about what you do on brakes. If you suspect you've got a problem with these, don't take a chance on them. Replace them. If you look at this, it's got a Teflon inner core. It's got a Kevlar braid. It's got some stainless steel braid. It's got a thick, tough, protective rubber coating on the outside of it. So it's wrapped with 2 or more layers of flexible webbing. Should never be pinched, kinked, or bent tighter than a specified radius. So take care of those things. Make sure that they're put on right. Now I want you to notice this fitting on the end. This is where this would hook to a brake caliper, and we're going to talk about it just a little bit. This is called a banjo type fitting, and we'll talk about that a little bit more in a minute. Here's a couple of brake hoses that have some issues. We're going to look them over for cracks, bulges, abrasions, or wear kinks. They can also have internal deterioration causing blockage of the passageway. Here's one that's been rubbing on something and it's damaged the hose. Here's one that's looks like improperly installed and it's kinked. Both of these hoses would need to be replaced. Talked about a little bit a minute ago there about banjo fittings. They're used to connect the wheel to the brake hose to a wheel unit, not on everything, but on some vehicles. It says they're comprised of a banjo fitting, a banjo bolt, and 2 copper or aluminum sealing washers. And it says the banjo bolt and fitting and wheel unit usually have sealing ridges machined into them. So here's what we're talking about. This is our brake caliper over here. It's got a machined surface right here, a nice, smooth machined surface. And this is a copper washer. And we have a machined surface on this banjo fitting and another machined surface over here, and then our banjo bolt. So what happens is these copper washers are soft, they compress, and they conform to any irregularities here, so they seal up nice and tight. Now this bolt should always be torqued. There'll be a torque spec for it. We want to torque that banjo bolt. The bolt on the inside is hollow, and it's got holes drilled in it for brake fluid to pass through it. These copper washers, they're not reusable. If you get a new brake hose, it should come with 2 new brass washers or copper washers. And if it doesn't, buy 2 new copper washers. You can't reuse the old ones. Like I say, they compress when you bolt them down, and they only compress 1 time. So you need to replace those each time you have these out. The hydraulic braking control system. The hydraulic system must be controlled accurately to maintain adequate control of the vehicle during braking. The working pressure is equally applied throughout a sealed hydraulic system. Remember Pascal's law. So hydraulic braking system can be designed to optimize the output force at each wheel of the braking units. Remember how we do that. Pascal's law said the pressures are going to be the same. So if we want more force, we're going to increase our surface area that we're pushing on, right? Components such as proportioning valves, metering valves, pressure control valves, and analog hydraulic control units are used to modify pressures within the hydraulic braking system. So, proportioning valves. Proportioning valves, they control the amount of brake fluid that goes to the rear brakes. All right, they reduce the brake pressure to the rear wheels when their load is reduced during moderate to severe braking. So we don't want the rear. If we have a real light load on the rear, we don't want to put a lot of pressure on the rear brakes when we apply them to have those lock up. So this proportioning valve prevents that from happening. Now the proportioning valve can be pressure sensitive. It's usually done in the master cylinder, or it can be load sensitive. If it's load sensitive, it's going to have a valve that's mounted to the axle housing, and we'll see a picture of that here in a minute. The pressure sensitive valve is in the master cylinder, or it can be a separate unit in the brake circuit. But the load sensitive is mounted on the body or on the rear axle. And effectiveness of braking force is determined by tire to road friction. Remember, we talked probably on about the first day we talked about brakes. I talked about the importance of the tires and how small a contact area you actually have with the road with these tires. So the effectiveness of the braking force is determined by the tire to road friction. Whether we're accelerating or stopping or turning, that tire contact area is extremely important. Load transfer, where weight is being transferred from the rear wheels to the front wheels. Remember, once we step on the brake, because of those rotational forces, the front end of the vehicle is going to go down, the rear of the vehicle is going to go up. So we're going to transfer weight to the front. This is if equal braking force is applied to the front and rear wheels during load transfer, the smaller load on the rear is going to cause the rear wheels to lock up. So because we've transferred so much weight to the front, there's no weight on the rear. If we had the same load applied, the same force applied, the rear wheels would lock up. So a pressure-sensitive proportioning valve reduces the pressure applied to the rear brakes under heavy braking. It said if the vehicle is equipped with ABS, it may not be equipped with a proportioning valve. That would all be done electronically in the ABS unit. Pressure-sensitive proportioning valve, again, generally this is all done in the master cylinder. It adjusts the braking force to allow for load transfer or variations on loads. It's got a poppet valve that's held against a retainer by a light return spring, and brake fluid passes freely through the pressure-sensitive proportioning valve to the rear brakes. During heavy braking, the master cylinder pressures reach the poppet valve's crack point, and which is here, and it's going to reduce if there's no load on the rear. It's going to reduce the pressures to the rear of the brakes. It says, as a result, the piston is forced back, opening the poppet valve and allowing pressure to rise to the rear brakes. It said a diagonally divided system requires one proportioning valve for each rear wheel. So I pointed out on the slide earlier that if we have a diagonally divided system, we need 2 proportioning valves. Because remember, we're only controlling fluid to the rear brakes. So if we have one system that's hooked to the left front and right rear, and the other one's hooked to the right front and left rear, then we would have to have 2 proportioning valves to control brake system pressure to both rear wheels. So the valve operates similar to the pressure-sensitive proportioning valve in the master cylinder, but without the pressure differential warning light. And talk about that. We'll talk about this switch here in a minute. This is very important also. Adjustable proportioning valves. Some high-performance vehicles have adjustable proportioning valves where they can control how much how much brake pressure goes to rear wheels. It says it's not recommended for most applications due to the amount of trial and error necessary to get them set properly. So it's too easy to get them jacked way out of shape and get yourself in trouble by having those adjustable ones. So they have the ones that are just built in and preset. Load sensitive proportioning valves, a little different animal. What it does basically is it has a valve that's usually mounted to the bottom of the body or to the axle housing. And off of that valve, there's an arm. There's an arm that comes off of that sets at an angle. Now, if we've got a pickup truck or whatever type of a truck and there's no load on the rear of it, we're not hauling anything around like most people do with their pickup trucks. The back of it's empty. That arm that comes off of that valve is going to be setting up, and we're not going to have much brake to the rear wheels because we don't need it. But as we start, say we pull in and buy a load of cinder blocks, and we start stacking those blocks in the bed of that truck. As we do, and we start getting that bed loaded, and that body starts coming down because of the load, that arm there is going to start coming down with it. And as it does, it's going to increase the fluid flow to the rear brakes. So the more that we load that body down, the more that adjusting arm is going to move, and it's going to allow more brake fluid to the rear brakes when we go to stop. As soon as we unload it and the body goes back up, that arm straightens back out, and we've got lower pressure to the rear brakes again. And that's just kind of how they work. This is a little bit of a picture of it. Here's the arm that I was talking about. They call it a connection link. But again, as the body moves up and down, it's going to move this arm, and when it does, it's going to control how much fluid goes to those rear brakes. Electronic proportioning valve, again, it's controlled by a computer. There's not really much you can do. It's handled electronically and can compensate for differences in traction by monitoring wheel slip. Metering valves. A metering valve is used to slow down the application of the front brakes. Remember, we've looked at some rear drum brake units out in the lab, and they have return springs that keep those pistons, or keep those brake linings pulled in against their stop. So when we apply the rear wheel cylinder, we have to overcome those springs before we can start to apply the rear brakes. So we would like for all four brakes to start to apply at the same time. So what happens with this metering valve is we slow down. It says to hold off the application of the front brakes on vehicles with disc brakes on the front and drum brakes on the rear. So again, we have a disc drum set up, discs on the front, drums on the rear. And because we have those return springs on the rear, we have to overcome that spring pressure before those rear brakes can start to apply. So what this does, this holds off those front brakes till the rear brakes have a chance to catch up. So disc brakes use the square cut O-ring to return the caliper piston to its rest position. Remember, inside that brake caliper, we have a piston in there, and then we have an O-ring that seals that piston. It goes all the way around. There's a groove cut inside the caliper, and this square cut O-ring sits in there. And the piston pushes through it, and the O-ring seals the piston to that bore in there. Well, as we start to apply that piston and it starts to come out of the bore, it distorts that O-ring, that square cut O-ring. It distorts it. It tries to stretch it. And so when we let the pressure off, and that piston, that O-ring works like a rubber band almost, and it pulls that brake caliper back to its rest position. So anyway, that's the way they return. So when the hydraulic pressure is off, then that O-ring can return that to its rest position. It says vehicles typically handle better when the rear brakes engage before the front brakes. So what they're trying to do is, again, they're trying to give the rear brakes a little bit of a head start to get them out against the drums before we engage the front brakes. It says the metering valve keeps the front brakes from being applied until the rear brake drums have a chance to overcome the tension of the return springs. And of course, if we have disc brakes on the rear, we don't need a metering valve at all. Metering valve operation, again, it works like a radiator cap. As pressure rises above the metering valve's crack point, fluid flows from to the front disc brakes and starts to apply the front brakes. So it's It's just got a metering valve, and it's got a spring and a check valve in there. As pressure rises, that would be sufficient for the rear brakes to start to apply. That's this valve's crack point and allows the disc brake calipers to start to apply the brakes. It says most metering valves are designed to be manually held in the open position to allow for bleeding of the brake system to take place. And this is a picture of one. As vehicles equipped with diagonally split systems are generally front drive and do not use metering valves for two reasons. Again, if we have a front wheel drive vehicle, we have so much weight in the front and almost no weight in the rear. So we want to just go ahead and apply the front brakes as soon as possible so the metering valve doesn't even come into play there. Pressure differential valve. It monitors any pressure difference between two separate hydraulic brake circuits. Remember, I talked about on modern systems, we have two separate circuits. So in case one goes out, the other one still works. If there is a pressure difference between the two, so we have a leak on one side or the other, this pressure differential valve can monitor that, and it knows when there has been a loss of pressure on one side. He said if there's a moderate leak anywhere in the system, it will eliminate the brake warning light in the instrument panel. So let's go look at this. Here's what it looks like. Here's our pressure differential valve. This goes to the front brakes. This goes to the rear brakes. This little switch here is very important. You see what's happened here is we have a leak at this brake line up here. So what's happened, because we have a leak there, remember if we have a leak, we can't build any pressure. But this other circuit is fine. We can build plenty of pressure. Because of that, this valve would normally be set right in the middle. And this little plunger right here on this switch would be set right down into this groove, and it would be set in the middle. But because we have a leak over here, we've got pressure on this side, none on this side, it forces this valve in this direction. When it does, see this little ramp, this little angle right here, it makes it real easy as this moves over for this little switch to come out of this groove, slide up this ramp, and be pushed upwards. When it does, it provides a ground for this bulb on the dash. And remember when we talked earlier about the float switch for low brake fluid, we'll turn on the light on the dash. This is the same light. So if that light comes on, there's 4 ways to turn it on. We've talked about 2 of them already. One of them would be if you're low on brake fluid, and that little float switch can turn the light on. The second will be this pressure differential switch. If we lose hydraulic pressure on one side, this valve is going to move to that side. When it does, it's going to go up one of these ramps, and it's going to push this up, and it's going to make a connection, give this bulb a ground, and it's going to turn on the light. That's 2 ways. The other 2 ways are this. When you step on the park brake or apply the park brake, it's got a little switch on it that when you set the park brake, it lets that switch close and provides a ground to turn that bulb on, same light. And the 4th way that it would come on is there's a self-check. When you go to start the vehicle, it will momentarily ground it and let it come on so you can check the bulb. So that's the 4 ways that we can turn that light that says brake that's on the dash. We can turn it on with a bulb check when we start the vehicle. We can turn it on by applying the park brake. We can turn it on with this pressure differential valve if we have a hydraulic leak, or we can turn it on with the float valve in the master cylinder if we have low brake fluid. 4 ways we can turn that light on. Now, when we have this this valve all the way in one direction, and we have this switch set, all right? Sometimes, most of the time, if you go up here and you fix this leak, and then you bleed the brakes, get all the air out of it, when you step on the brakes, it will force this back into the middle. This will go back to its original position, and everything's fine. Some vehicles that won't work. Some vehicles that won't work. When that thing's all the way over, for it to move, because you've got equal pressures on both sides here, it's going to stay where it is. So what you have to do in some vehicles is set in the car with the key on. The brake light is going to be on, again, because this switch is closed, so the brake light's going to be on. So what you have to do is you have to set in the vehicle with the key on, the brake light on, your foot on the brake pedal, have somebody loosen one of these on this side, and slowly push on the brake pedal. When you do, now we've got a leak on this side. So the pressure over here is going to start moving this back. When it gets to the middle, this little plunger is going to come down, the brake light's going to go off, stop pushing on the brake pedal at that point, and have somebody tighten this fitting. And then you're back set. Now, I've had them before that I just never could get the doggone things to reset. My Torino that I've been restoring, what I had to do on it was I just unscrewed this switch and got in here with a little screwdriver and just moved this over until I got this where it was supposed to be in the middle, and then screwed the switch back in. So just different ways of having to do that. Combination valves, again, guys, different manufacturers. Here's a combination valve. It has the pressure differential valve, metering valve, proportioning valve, all in one unit. And you can have any combination of there in there. This one you see our brake warning switch here on our pressure differential valve. This one is centered like it's supposed to be. Anyway, this combination valve just can have any combination of metering valve, proportioning valve, or pressure differential valve, all in one unit. And some of them do, and some they're all separate. Brake warning lamps and stop lamps. Again, we're talking, two different things. Brake warning lamp is the light that comes on the dash that says brake, which is separate and from an ABS light, by the way. And the other one, the brake, the stop lights are the lights on the rear of the vehicles. The brake warning light, we've already talked a lot about it. A single light located at the instrument panel, whereas the stop light is made up of at least 3 lights at the rear of the vehicle. Brake warning light, we've talked about the way that we can light it. The parking brake is engaged, it turns it on. The brake level is low, it turns the light on. Unequal pressure in the hydraulic system, we'll turn it on. And a prove out or proofing circuit when we start the vehicle is the 4th way. And here's the circuit for that. We've got a battery here. Of course, it's grounded. And we come out off the positive side. We've got a fuse. We go to the ignition switch. Key turned on. Goes over to the bulb. So we've got voltage to one side of the bulb, but we've got no ground. So the light won't work. We don't have a completed circuit. There's no light. Now, if we set the park brake, when we set the park brake, this little switch is allowed to close. It's hooked out here and it goes to ground, so the bulb's going to come on. Or if our float switch goes, if we get too low on brake fluid and our float switch goes down, again, it's going to close this switch. It goes out to our ground and turns the bulb on. Our pressure differential switch, that little switch that screws in the top, if it moves to one side, it closes this switch. And it gets a ground here and turns the bulb on. And then here's our proofing circuit from when we turn the key on. Any of those that provides a ground for the other side of this, will turn the light on. Stop lights, designed to warn others that the vehicle is braking. They're mounted on the rear of the vehicle and must conform to federal laws for brightness and location. They're activated by a normally closed stoplight switch located in the brake pedal assembly. So here's our brake pedal. The brake pedal is released, and when it's released, this little plunger is pushed in, and there's no contact. So the brake lights are not on. When the brake pedal is applied, when it's moved in this direction, this plunger is allowed to come out. When it does, it makes contact, and it turns the brake lights on. It's as simple as that. This is a center high mount stoplight located higher than the regular lights near the center line of the vehicle, designed to be more in the driver's line of sight while he or she is looking down the road to anticipate traffic hazards. And hopefully we'll catch their attention when they're looking at their cell phone. Power brakes. We'll talk a little bit about power brakes here. Got 2 types. We have some of them that have a power booster. Or power brake unit that uses an external force to multiply the driver's effort. So what we're trying to do with power brakes is help the driver to apply the brake pedal. 2 main types: vacuum assist and hydraulic assist. The vacuum assist type, here's our booster. It's got a big diaphragm inside it. Of course, here's our master cylinder and here's our brake booster. It's bolted to the firewall. It's the vacuum assist power booster, operates between the brake pedal and the master cylinder and uses the difference between engine vacuum and atmospheric pressure to increase the force that acts on the master cylinder. So So we've got this big diaphragm, and it's got a vacuum hose and a check valve that goes over to the engine, to the intake manifold on the engine. Here's the other style. It says hydraulically assisted power steering operates between the brake pedal and the master cylinder, uses hydraulic pressure from the power steering pump. So we can take hydraulic pressure as the power steering pump builds pressure to operate the power steering. We can also use that pressure to come over and help us with the power brakes. On our vacuum boosters, most of them have one diaphragm. Some of them have two smaller diaphragms that are hooked together. That just reduces the overall diameter and size of it, and it gives us kind of the same braking power with two as we have with one, but we can make it a lot smaller where we can fit it in the engine compartment. Again, two diaphragms allow the diameter of the booster to be smaller. Pretty easy. These are not very complicated, actually. Again, here's a check valve. This goes to the engine intake manifold, so that's where we get our vacuum. We start the engine up, we put vacuum, got a big diaphragm in here and a spring. The spring keeps this diaphragm pushed back. So when we start the engine up, we've got vacuum on both sides of that diaphragm. So it stays in place because the spring is holding it there. Once we step on the brake pedal, we release the vacuum on the back side of this diaphragm. And when we do, we have enough vacuum on this side to pull this forward, and that helps us to apply the brake pedal. So when we let the pedal up, the vacuum again comes to the back side of this, and the spring pushes it back, and we've got no assist again. So all we do when we step on the brake pedal is we lose this vacuum, and it lets this side pull the brake pedal forward. The check valve here will keep vacuum in this booster even when you shut the engine off, so that if you was driving down the road and your engine died, you can still have enough vacuum in here to get the vehicle stopped, maybe one time. Vacuum booster operation. When the driver steps on the brake pedal, it moves the brake pedal push rod forward and transmits movement through the power unit to the master cylinder piston to apply the brakes. A hose connects the intake manifold to a vacuum check valve on the power brake unit. A vacuum in the intake manifold is used to evacuate the power brake unit. In other words, pull a vacuum on it. It says the valve holds the vacuum in the booster in case of an engine failure, and it allows at least one boosted brake application. As our brakes are applied, the pedal push rod and plunger move forward in the diaphragm plate, which brings the vacuum valve into contact with the vacuum port seat. Further movement of the push rod moves the atmospheric valve away from the port, away from the seat. The difference in pressure now on both sides of the diaphragm moves the diaphragm plate forward, applying greater force to the master cylinder. So again, as long as we got the same amount of vacuum on both sides, that big spring on the front is going to keep it pushed back. Whenever we drop that vacuum on the back side, we got enough vacuum on the front to pull that forward, overcome the spring, and apply the brakes. Once the pedal stops moving, the atmospheric pressure continues to build up in the rear chamber, and then and when it gets even, this spring can push it right back to the rest position. During application, the reaction force against the valve plunger works against the driver to close the atmospheric port. When the force on the pedal is held constant and both the vacuum valve and the atmospheric valve are closed, the valve always returns to the hold position. When the pedal is released, the atmospheric valve is closed and the vacuum valve opens. And when the engine is switched off or stops for any reason, no manifold vacuum is available to supply the booster. Remember, we do still have some vacuum on that because of the check valve. Dual diaphragm boosters, guys. Dual diaphragm boosters work just like a single diaphragm booster. It's just that we have two smaller diaphragms rather than one large one. To keep the surface area of the diaphragm plate large enough to provide the boost that's needed, two smaller diaphragms in tandem are used. Separate vacuum and atmospheric chambers for each diaphragm plate. The same control valve concepts are used and therefore apply, hold, and release in the same manner as the single. So they're the same as the other. Then the other side we have again is the one that uses hydraulic pressure from the power brakes. And we're just about done here in case you was wondering. Again, uses hydraulic pressure from the power steering pump to provide the required power. suitable for engines with or vehicles with diesel engines. Guys, if you don't make a lot of vacuum, or diesel engines don't make any vacuum, so we wouldn't have any way to get vacuum for a vacuum booster. So we use this type of hydraulic brake booster. Also, some vehicles just don't have enough room under the hood for the booster, and so they might use this type of hydraulic booster also. And guys, what they do is, here we got pressure coming in from the pump. We've got a port here that goes to the power steering. We've got a lever that moves back and forth that helps us to apply this. So what happens is, basically, as we step on the brake and we move this lever, it opens up a valve here. It lets pressure come in here, press on this, and it's going to move us forward. It's going to help us apply the brakes. If we lose the engine, if we don't have the power steering pump, or we throw a belt off or something like that, we have another little section down here that's got nitrogen gas in it. It's called an accumulator, what this nitrogen gas will do, it will supply enough pressure for us to make a couple of brake applications with power brakes. Guys, most of these units, there's nothing. If there's something goes wrong with them, you just replace the entire unit. You're not going to go in here and fix anything in here. You would just replace this unit if it goes bad. It's on the hydraulic system. The master cylinder portion of the system still uses brake fluid. Guys, be darn sure you don't mix these fluids, okay? Because, man, if you get some sort of hydraulic fluid or power steering fluid or something like that in your brake master cylinder, it will mess up everything. You'd have to replace, oh goodness, you'd have to replace the master cylinder, all the wheel cylinders, all the rubber hoses, the brake calipers, probably the ABS unit. So make sure that you get when you put brake fluid in this thing, make sure you're getting the right stuff. If it's supposed to have .3 or .4, put it in there. If it's supposed to have .5, put it in there. These brake fluids don't mix. Put the right stuff in there. Make darn sure you've got the right stuff. Again, the booster can generate pressures of 12 to 2,000 psi to help activate the master cylinder. And the accumulator, again, that was that little accumulator down here. It assists in maintaining a reserve system of pressure. Accumulator is designed to store sufficient pressure to provide for a few full power applications in case of engine stalls. Electro-hydraulic braking, again, basically it's the same as a hydraulic pump, but the little motor is electrically driven and instead of belt driven. So it says battery power is used only when needed instead of continuously from the power steering pump. Because only when we need the pressure will this little motor turn. No chance of problems because such things as a worn power steering pump or slipping belt or a leaky hose or anything like that. So electro-hydraulic braking still uses hydraulics, but it uses electric motor rather than a belt-driven pump. So to summarize this very quickly, principle behind hydraulic brakes is Pascal's law, which states that pressure applied to fluid in one part of a closed system will be transmitted without loss to all other areas of the system. Any substantial leak in the hydraulic system will prevent it from building enough pressure to apply braking force. Engineers design brakes that have precise but unequal amounts of braking force at each wheel. Remember, we may need more braking force at the front and rear, and the engineers design that way. The three variables related to pressure and force in a hydraulic system are input force, working pressure, and output force. The main components of a hydraulic braking system are the pedal, the brake fluid, and the master cylinder. The brake pedal multiplies force from the driver's foot to the master cylinder. Brake fluid has a high boiling point, a low freezing point, and is hygroscopic, which means it absorbs water. Department of Transmission grades brake fluids on pH value, viscosity, resistance to oxidation, stability, and boiling point. Remember, if we got .3 or .4, .5, whatever it is, put the right brake fluid back in it. Master cylinders convert force exerted from the brake pedal into hydraulic pressure to activate the brake units. So the force that we put in with our foot is transferred into hydraulic pressure to apply the brakes. Types of master cylinder are single piston and tandem. And again, remember, almost everything has got a tandem or a dual system now. A single piston master cylinder uses a cup to seal pressure in the cylinder and a secondary cup to prevent fluid loss out the back of the master cylinder. A single piston master cylinder traps brake fluid and forces it into the brake lines. Residual pressure valves used on drum brake systems to maintain brake fluid pressure and prevent air entry when the brakes are off. Modern vehicles have tandem master cylinders to ensure braking ability in at least one circuit despite a leak. So if one side fails, the other one works. Pressure differential switches monitor the loss of pressure between the hydraulic units. Remember, if we lose pressure on one side, that little valve is going to move to the side of the loss of pressure, and it's going to turn on our light for us. Remember that our split systems can be split front to rear or diagonally. The diagonal type systems are going to retain 50% capacity even if the system fails, because we're going to have one front and one rear. Remember, quick take-up master cylinders work to compensate for large clearances, running clearances between low drag brake calipers. So on the ones that the brake calipers retract some and pull the pads away from the rotors, we need to take up that space. That's the purpose of quick take-up master cylinder. Hydraulic systems use proportioning valves, metering valves, and pressure differential valves, or analog hydraulic control units to modify hydraulic pressure. Proportioning valves reduce brake pressure to the rear wheels, and our pressure can be pressure or load sensitive. Remember that our proportioning valves are going to control brake fluid to the rear brakes to try to keep them from locking up. Metering valves try to ensure that the rear brake pressure is applied before the front brake pressure, so we can overcome those springs in the rear. And sometimes we've got combination valves that can incorporate all of those different things in one unit. Brake warning lights alert drivers to engagement of the parking brake, low brake fluid, unequal pressure in the hydraulic system, or again, the check when you turn the key on. Stop lights are mounted on the rear and alert other drivers to the vehicle being stopped or braked. As of '86, all vehicles must have a third timeout brake light. Power brake units use either vacuum assist, which is the most common, or hydraulic assist. Vacuum units can be single or dual cylinders. This is a 12-inch vacuum booster is capable of generating enough PSI to stop a vehicle weighing thousands of pounds. The vacuum booster works off the difference between manifold vacuum and atmospheric pressure. So again, that's the way those things work. Guys, that's it for the lecture tonight. I hope that doing this way has been helpful, and I'll see you in class very soon.